our solar system. In this lesson, we're talking about all the objects within our solar system, including the Sun and the 8 planets: Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, and Neptune. We're also going to touch on the Great Red Spot on Jupiter as well. And lastly, we're going to talk about why Pluto isn't one of the planets anymore, specifically what makes it different from the other ones and why it was demoted. Our solar system. Our solar system is made up of the Sun, the 8 planets, some moons, and many comets as well as asteroids. And you can see our solar system right here. So at the center of our solar system, we have the Sun, which gives off its own light. It's the only thing in our solar system that does. We have Mercury, Venus, Earth, Mars. We have the asteroid belt here: Jupiter, Saturn, Uranus, and Neptune. And then outside of all this would actually be another asteroid belt called the Kepler belt, which isn't shown on this picture, but it's filled with asteroids as well. And they're much more spread out, and it's actually where Pluto is located. The Sun. The Sun is composed of 75% hydrogen and 25% helium by mass. The Sun uses fusion to combine two hydrogens to form helium and a lot of energy. And that energy is the key. That's the energy that powers our planet. Now, to allow this reaction to occur, we need to have certain core conditions. We need to have a really high temperature. The temperature of the core of the Sun is 15.6 million Kelvin. We also need a very high pressure. The pressure inside the center of the Sun is 250 billion times more than on Earth. It's that pressure and temperature that allows fusion to occur inside the Sun. If you want to check out video number 1, it's a really interesting video put on by NASA. It's short, but it covers a pretty good time span of different events that have happened on the Sun, as well as some beautiful imagery. Now, the Sun is huge. That's one thing we've got to really keep in mind about the Sun. It makes up 99.8% of the mass of our solar system. So hypothetically, if our solar system weighed 100 kilograms, the Sun would be equal to 99.8 kilograms. And everything else, that's all of this stuff, plus the asteroid belts, would be 0.2 kilograms only. It's amazing to think how much of that mass is actually just the Sun and how little of it is everything else. Now we're going to start with the inner planets. The inner planets include Mercury, Venus, Earth, and Mars. And they're all known as rocky balls, which differentiates them from the outer planets, which are mostly composed of gas. So first up is Mercury. Mercury has the shortest orbit around the Sun. That's because it's the closest to the Sun. If you take a look at our picture here, Mercury is the one closest to the Sun. Therefore, it has the shortest path around the Sun. Shorter path, shorter year. Compared to Earth, Earth's diameter is about 2.5 times larger, and Mercury is simply a rocky ball floating in space. Venus. It's also known as our sister planet. It's very similar to Earth. It's closer than Earth, but further than Mercury. You take a look at our picture again. This one's Venus right here. You can see it has a slightly larger orbit because it's going to have a further distance to travel to get around the Sun. It's also a rocky ball, but it has a huge greenhouse. Now, the greenhouse around Venus traps a lot of the heat inside, so it makes Venus really, really hot. In fact, you can get all the way up to 800 degrees Fahrenheit just because of that greenhouse effect. Now, this makes Venus not a very plausible place for us to go. We would need to dissipate that atmosphere to bring it down to temperatures that we could withstand. Now, that's unfortunate because, as I said, Venus is very similar to Earth in terms of size, length of day, all that kind of stuff. So it would make for a good candidate if it was more habitable. Earth, the only planet in the universe that we know has life, is the third rock from the Sun. It has an orbit of 365.25 days. That's why we have a leap year every 4 years to compensate for these 0.25. And one of its key points is it has a breathable atmosphere containing mostly nitrogen and oxygen, which allows us to survive on Earth. It also has a magnetosphere, which protects us from the harmful solar rays coming from the Sun. Mars. Mars has been in the news a lot lately. It's one of those places that we could potentially inhabit in the near future. So Mars has solid carbon dioxide at the poles. That's what these two arrows are pointing to. It's known as the red planet because of the rust covering the entire surface, which gives it that red color. It has an orbit of 1.88 Earth years, so it takes a little bit longer to get around the Sun. It's a little smaller than Earth. Earth's diameter is a little bit less than 2 times as large. Again, it's a rocky ball, and there's no breathable atmosphere, which would make it difficult for us to colonize. If we do want to colonize it, we need to do something called terraforming, which video number 2 talks more about. But in essence, terraforming means changing a planet into something that is better suited for you. And you can see the difference between Earth and Mars. Okay, so we finished with the inner planets. The inner planets are all those rocky balls. The outer planets are going to be more our gas giants. But you can see they're really big, but they're nowhere near as large as the Sun. Jupiter. Jupiter contains over 70% of the mass of the solar system outside the Sun. So remember we talked about that 0.2 kilograms that were left over? Well, 70% of it belongs to Jupiter. It's a ball of gas and liquid, mostly hydrogen and helium. And if it were larger, it would actually be a star. It's composed of the right stuff. It's just not big enough to have enough pressure and temperature in its core to undergo that fusion reaction. And its diameter is 11.1 times larger than Earth, and you can see it compared to Earth in the bottom right-hand corner. One of the really interesting things about Jupiter is its giant red spot, and you can see it right here in the picture with the red arrow. Now, that big red spot is a storm that's been going on for at least 400 years, and we're not quite sure how long it's going on for, or what started it, or how long it's going to be on for. But it's a huge storm. That storm is, in fact, larger than the Earth. You could fit about 3.5 Earths across that storm. That's how large it is. If you'd like to learn a little bit more about the storm, video number 3 talks about it. Saturn, a very distinctive planet due to these rings that go around it. It's also made of gas. One of its moons, Titan, is larger than Mercury. It's identified by its many rings composed of ice particles. It has an orbit of 29.46 Earth years, so it takes a very long time for that planet to go all the way around the Sun and come back. And its diameter is about 9.41 times larger than Earth. And you can see Earth compared to Saturn in the bottom right-hand corner. An interesting side note about Saturn is that eventually those rings will be pulled into the planet and won't have that really distinctive, interesting ring structure that it currently has. But that's billions of years from now. Uranus. Uranus is also a gas giant. It has a very thin ring system, which you can see in the picture right up here. So nowhere near as big as Saturn's. Its atmosphere is composed of methane gas, giving it the blue color. It has an orbit of 84 Earth years, so it takes 84 Earth years to go around the Sun. Its diameter is 4 times larger than Earth. You can see that in the picture on the bottom right. And it's flipped on its side, and we're not quite sure why it's flipped on its side. We know it's flipped on its side because of the ring structure. So you're going to have the poles here and here. One idea that could have caused it to flip is that it could have had a collision with another large object in space, which could have knocked it on its side. But again, we're not quite sure. And our outermost planet, now that Pluto is gone, is Neptune. Again, it's made out of gas, mostly methane gas, similar to Uranus. And that's what gives it its blue color. It has a very thin ring structure, which you can't even see in this picture, and has a giant orbit. It takes 164.8 years to go around the Sun. And its diameter is almost 4 times larger than Earth's. So here's our solar system. We have Mercury, Venus, Earth. There's Earth's moon. Mars is out here. Then we have Jupiter, Saturn, Uranus, and Neptune. And then we have all this guy right here. That's going to be our asteroid belt that goes around the Sun between the orbits of Mars and Jupiter. Now, when I was in school, Pluto was considered a planet, and many textbooks still have Pluto as the 9th planet today. It was in the early 2000s that it actually got demoted and is no longer considered a planet. It's considered now a dwarf planet. And it's not even the largest dwarf planet. It's the second largest dwarf planet after Aries. Now, its mass is only 0.24% that of Earth, and its diameter is roughly 66% of the moon. And you can see the comparison. There's Earth, there's the moon, and here's Pluto, smaller than the moon, and yet it was considered a planet before. So why was Pluto demoted? Well, first of all, it's really small. It's smaller than the moon, so that's one strike against it. There were simply too many similar objects. There's way too many things floating around in space, so instead of adding thousands more planets, they just simply removed one. And lastly, it has a very strange orbit. You can see the orbit down here. There's the regular orbit down here. Here's the regular orbit of all the other planets. You can see they're all on the same ecliptic. But Pluto has this weird orbit that actually crosses Neptune's orbit. So you get a little bit more information about why Pluto is demoted in videos 4 and 5. Observing stars and planets. So what makes a star a star? Well, a star is a big ball of burning gas. Like I talked about, we have hydrogen plus hydrogen gives us helium and lots of energy. Hydrogen and helium are both gases, and it's that intense pressure and temperature inside the sun that makes fusion occur. A planet, on the other hand, is a smaller ball of rock or gas that goes around a star. The sun and all the other objects that travel around make up the solar system. So we have a solar system, but every other star will have its own individual solar system as well. We say the sun is luminous because it produces its own light, whereas planets and moons are called non-luminous because they cannot produce their own light. Instead, they reflect the light that comes off the sun. So the light from the sun hits the Earth, bounces off, and it makes it appear to illuminate. But really, it's just a reflection from the sun. The moon. The moon takes about 28 days to orbit the Earth. The moon has several effects on Earth, including tides, nighttime illumination, tilt, and rotational speed. In fact, if we lost the moon, we'd be in a lot of trouble. And Earth's diameter is about 3.7 times larger. And you can see a couple interesting pictures here. Top right is just your general picture of the moon. The second picture is of Neil Armstrong during his historical moon landing in 1969. And then the third picture is pretty cool because it's a picture of Earth from the moon itself. And that concludes our lesson on the solar system.